Hello everyone and welcome to this video on bus stop division and double-decker bus stop division. If you're homeschooling your child and you've ever reached that moment in maths where division feels a little bit intimidating and you're definitely not alone, or if you're supporting your child at school with their mathematics, division can be that topic which feels like a little bit like an unexpected guest who's arrived without any instructions. So in this video today we're going to be looking at bus stop division and double-decker bus stop division. If you're here just for double-decker bus stop division, I recommend that you skip to the end of the video. Okay, bus stop division, what is it all about? Well, the idea is that, and the name comes from the idea that the structure we use here on the left is similar to a bus shelter or a bus stop here on the right, and that's basically where the name comes from. So we use this structure to basically go through a small kind of process that we're going to look at and how to divide large numbers, and that's the reason for using this structure. But before we do that, there are a few key points that your learners at home need to know before jumping in and using this method. The first thing is they know what division is. It's about sharing a specific number evenly, splitting up a value, or knowing through context. For instance, if you had £10 and you're going to share it amongst two friends, how much money would they get each? It's really kind of understanding that concept of sharing or splitting something up evenly into groups. They need to also realise that division is repeated subtraction. So often multiplication is described as repeated addition, and division is therefore described as repeated subtraction. So if I had, say, the number 32 and I was to take away 8 repeatedly, how many times do I have to do that to get to 0? It's kind of that way of thinking as well, and that's another way of thinking about division. Having secure times tables, this is going to really help your children if they're really secure up to at least their tens. This is going to just stop any potential barriers from getting through the process. And then finally, understanding about remainders and leftovers. Now, what I mean by that is if I had these, if I had 8 footballs like I've got in the illustration below, and I wanted to split them up into 3 groups, how could we do that? So if I was to split these into one group, and then I'll split these up into another group, and therefore I've got 2 left over. So I could put them into 2 groups, but I'd have 1 even group, and that's what we mean by having a remainder or a leftover. It's having an amount that doesn't match the other amount, so it doesn't fit in. So that's what we mean by remainders and leftovers. So how the structure works is if we were to pick, say, 64, and we were going to divide that by, let's go with 8. How this works is 64 goes inside the bus stop, and the number we're dividing by goes on the outside. And then the answer, well, 64 divided by 8 is going to give us 8. That would just go on the top, and that's where our answer would be. So that's how we use our structure, and we're going to go through 5 exercises that you can introduce to your young ones at home to show them the mechanics and how the bus stop method actually works. So this is the first exercise. So I call this the number goes evenly, and there's no leftovers, so there's no remainders from doing this. So the way that we treat this is we look at the number on the outside. That's the number we're dividing by, and everything on the inside is the number that's going to be divided. So we ask ourselves, how many 2's go into 2? Well, the answer is 1. And how many 2's go into 4? The answer is going to be 2. So what we are doing is we are doing a separate division sum with each of the digits inside the bus stop. That's effectively what we're doing. For question 2, how many 2's go into 4? There are 2, and again there are 2 in there. So 44 divided by 2 would be 22. Just referring back to the first question, 24 divided by 2 would be 12. And I would think at this point most children would be able to do this because we're effectively halving. So the point of this exercise is that the answers might seem really obvious, but it's just getting them into the practice of going through the bus stop method and practicing on things that they know. It's so they just understand the system that we're following here. So 2 into 8 goes 4 times, and 2 into 4 goes twice, and 2 into 2 goes once, 2 into 4 goes twice, and then 2 into 8 goes 4 times. I'll leave you the rest of the questions for a little bit of practice, you might want to pause the video now. These exercises will be available on a PDF as well. Just going over the last two before we move on to the second question. We go 2 into 2 goes once, 2 into 4 goes twice, 2 into 4 goes twice again as well, and then we've got 2 into 0. That's really important that kids understand that. So 2 into 0 goes 0 times. We have to make sure we put the 0 there. Okay. Right, moving on to exercise 2. This exercise is called the first number is too small, so we have to bring down the next number. This is where we introduce that concept of carrying when we're using the bus stop method. So we can see with all of the questions here, you might have glanced over that, recognizing that the first digit inside the bus stop is smaller than the number we're dividing by. So we know that that number's not going to go into it. So what we're going to do, okay, so first things first is 2 goes into 1. No, it doesn't. And it's nice to put a little place marker at the top there to go, no, it doesn't go in. So what we're going to do is cross it out, and then we're going to put a 1 there. And now how many 2's go into 4? And the answer is 7. So therefore we know, obviously we can probably do these in our head. 14 divided by 2 is 7. So that's where we leave that. It's nice to put the 0 there because that gets into the habit of doing a few other things that we're going to look in some other exercises later. So 2 into 1, again, that doesn't go. We cross it out, carry over the 1. So now it's 2 into 12. That goes 6 times. 2 into 1 doesn't go. So we cross it out, carry over that 1. And now 2 into 16 goes 8 times. 2 into 1 doesn't go, carry over the 1. Now 2 into 18 goes 9 times. 4 into 1 doesn't go, carry over the 1. 4 into 16 goes 4 times. I didn't put the 0 there. 4 into 1 doesn't go, carry over the 1. So now it's 4 into 12, and that's going to go 3 times. You might want to pause the video there and have a little go at the rest, and I'll go through questions 11 to 14 shortly. Okay, 5 into 3, that doesn't go, carry over the 3. So now it's 5 into 35, which goes 7 times. 5 into 3 doesn't go, cross that out, carry over the 3. Now 5 into 30 goes 6 times, and then 5 into 5 goes once. Question 13, 5 into 4 doesn't go, cross it out, carry over. 5 into 45 goes 9 times, and then 5 into 5 goes once. Last question then, 5 into 4, that doesn't go, carry over the 4. 5 into 40 goes 8 times, and then 5 into 5 goes once. It's really useful to use that language about how many times does this number go into that number, because then that helps visualize in your head as well. Using that language with your children I think is really, really important, because it helps them visualize and start to visualize what's happening with the divisions. Okay, question 3, well, the exercise 3, the number doesn't go evenly, so there's a leftover. So this is what we mean by a remainder. And this is crucial that we follow what's happening with this. So 3 into 4 doesn't go evenly. It will go at least once, and what is left over afterwards? It was like the thing we looked at right at the beginning with the footballs. Well, there's only going to be one value left over, because 3 to 4 is there's only one. The next question, 3 into 5 goes once, and that's remainder 2. 3 into 6 goes twice. That's nice because that does go evenly. 3 into 7, that goes 2 times, remainder 1. And the way that we can cross-check this is, we'll just do this quickly here. So 2 times 3 is 6. 2 times 3 plus that 1 equals 7. And the same for the beginning over here. 1 times 3 is 3. Plus the 2 equals 5. 1 times 3 is 3. Add that 1 equals 4. So there's a way of going back through it afterwards and double checking you've got it right. 4 into 5 is only going to go once, remainder 1. And hopefully you get the idea. I'll do a couple more. So 4 into 6 goes once, remainder 2. 4 into 8, that goes evenly, because 2 times 4 is 8. 4 into 9 is going to go twice, remainder 1. 5 into 6 is going to go once, remainder 1. And 5 into 9 goes once, remainder 4. So we can see, obviously, we're not quite, it would have gone twice if there was 10, but that's why we have the remainder of 4. Have a look at the others as a bit of a practice. Now we're going to move on to the fourth exercise. Okay, there's a leftover, so we bring the next number down. We're carrying over again. So what does this mean? We've got a different situation this time. So 2 into 3. We know 1, 2 will fit in, but there's a remainder. So before we were putting the remainder like this. We're not going to do that this time. Oh, where's my rubber gone? It's there. What we're going to do is that we know that remainder is 1, so we're going to bring it down and put it with the 4. So it's now 2 into 14. So that is going to go 7 times. Just like that. 2 into 3 goes once. The remainder is 1. It might be useful just to write the little remainder above, just so to keep count of what's going on. So then we bring that 1 down, and then 2 into 18 goes 9 times. 2 into 5 goes twice, and that is another remainder of 1. So bring that 1 down. And now it's 2 into 14. That goes 7 times. And finally 2 into 5, that's going to go twice, because 2 times 2 is 4. That's as close as we can get to 5. That's another way of asking or thinking about it. So what's left over? 1, we're going to bring that 1 down to 18. Now 2 into 18 goes 9 times. So question 5, 2 into 7, that's going to go 3 times. Remainder 1, because 3 times 2 is 6, and then 1 more is 7, so that's why we've got the remainder of 1. We bring it down, so now it's 2 into 12, that's going to go 6 times. You might want to pause the video now and have a little practice on your own at these the last 3, and then I'll go through those. Okay, question 6, 2 into 7, that's going to go 3 times, remainder 1. 2 into 16 goes 8 times. 2 into 7, that's going to go 3 times. Oh, sorry, 3 times, because 2 times 3 is 6. There's 1 left over, so now it's 2 into 18. It's going to go 9 times. And finally 2 into 9, that's going to go 4 times, because 2 times 4 is 8. But what's left over to get to 9 is only 1. Bring that 1 down, and now it's 2 into 12. That goes 6 times. Okay. You can make up these questions yourself as well. They're fairly easy to do, and we're all these questions here we're just dividing by 2, but it's just about understanding that process. It's not getting that concept. It's just getting them to practice that process. So this is a little bit more on extension 4, because this time we're going to continue carrying, but the numbers are getting bigger and bigger. We've got hundreds and we've got thousands going on here. So 2 into 3, that goes once. Carry over the 1, because that's the remainder. 2 into 14 is going to go 7 times, and then 2 into 2 goes once. So 2 into 5 is going to go 2 times, carry over the 1. 2 into 14 goes 7 times, and 2 into 2 goes once. And I'll do question 3 as well. 4 into 5 goes once, carry over the 1. 4 into 12 goes 3 times, and then 4 into 4 goes once. Question 4. 4 into 7, that's going to go once, and the remainder this time is 3. So we're going to bring down the 3, and it's good to have that variation, because if you're just carrying down 1 all the time, you don't want to just lock in that if there's a remainder, it's always going to be 1. It needs to be. Then that's why sometimes it's useful, as I was doing previously, to just make a little note of the remainder, what's left over, because that's always the number that's going to be carrying down. Now 4 into 32 goes 8 times. And then 4 into 4 goes once. On this side here, you might want to pause the video and have a bit of a practice on your own. And I'm going to go through questions 7 and 8. So 4 into 6 goes once, remainder 2. 4 into 24 goes 6 times. 4 into 4 goes once. 4 into 4 goes once again. 4 into 9 is going to go twice. And 1 carried over. That is a 2. 4 into 16 goes 8 times, 4 into 4 goes once, and then 4 into 0 goes 0 times. Okay, so that's exercise 5. Next exercise. So this, you get leftovers more than once, so we've got to be a bit cautious on this one. 2 into 3, that goes once, remained 1. 2 into 14 goes 7 times, and now look again, we're back here. 2 can't go into 3. But we know it can at least go once and then remainder 1 again. So now 2 into 14 goes 7 times. Okay, so that's why we've got more than 1 carrying over on these questions here. 2 into 3 goes once. Carry over the 1. 2 into 16 goes 8 times. And then we're literally just going to repeat again on this question here. Because if it's 36, then 36 again. That's what we're doing it. So just remember, that's what we're doing. We're treating each separate digit as a separate division question. We're not just dividing 3,636 by 2. Might want to pause the video there and have a go. And then I'm going to go through question 7 and question 8. Okay, question 7. 4 into 8 goes twice. That goes nice and evenly. 4 into 9, that goes twice, but there's 1 left over, so we bring that down. 4 into 13, we know that doesn't go either, but the closest it can go is to 12, because 3 times 4 is 12. And what's left over? It's 1. So now 4 into 16, that goes 4 times. Question done. Last one then, 4 into 8 goes twice. 4 into 1 doesn't go. So what do we do on this one? Yeah, we haven't looked at one of these problems yet, but because we know this is where we put the 0 up there, because 4 into 1 doesn't go, so we're going to cross that out and then carry that over. Now 4 into 13, that goes 3 times, and then remained 1, and then 4 into 16 goes 4 times. Just a bit of a quick kind of thought on that last question. If it didn't quite feel intuitive to stick that 0, what was it? It was 8, 1, 3, 6. And I put that 0 above there. You could quickly work out before doing these questions. If I've got 8,000, I'm dividing it by 4. We can mentally probably estimate that's going to be around 2,000. So if you think about putting these zeros in and you're thinking, oh, is it going to flip out there or adjust the place value in the wrong way? We can check the method's going to work by doing a very quick estimation before we've done it. But that's why putting that 0 is a really good habit of doing that, even if it's the first number that doesn't go, like we were doing, I think it was question exercise 2. Okay, double-decker bus subdivision. Just before we jump into this, there are a few kind of little things that you probably need to know before we do this. The first thing is that if you're introducing this to your children, they should already be very familiar with how to use the normal bus subdivision for short division. That is a key kind of component that we are going to be looking at this. So firstly, why is it called double-decker bus stop division? Well, it's literally just 2 bus stops on top of each other, kind of like a double-decker bus. And that's kind of the structure that we use for this. And why do we do this? So I'm just going to divide a normal number using just the short division method with bus stop. So we've got 5,632. We're going to divide that by 8. So we just go through the motions. We put our number we're dividing by inside. So the number we're dividing goes inside, the number we're dividing by goes on the outside, and we're going to go through this. So 5 into 8 goes 0 times, carry over the 5, but 5 into 56 goes 7 times, because 8 times 7 is 56. Now 8 into 3, that doesn't go. So we cross that out, we put the 0 up there, carry over the 3. Now 8 into 32 goes 4 times. So quite quickly, we can see that 5,632 divided by 8 equals 704. Now this time I'm going to do it again, but I'm going to do it using the double-decker bus stop method. Now before we do this, we have to consider 2 factor pairs of 8. Now this is a crucial part to understanding double-decker bus stop division. The number we're dividing by, we're going to split it down into 2 smaller factors, and they have to be a factor pair. So what I mean by a factor pair is they have to multiply to make that number. So if your children aren't familiar with factors, or they're not familiar with factor pairs, this is a crucial step that they need to understand first before having a go at this method. So I've picked 2 and 4 for 8. Now there's only one other factor pair, and that'd be 1 and 8. And as you'll see in a minute, that factor pair wouldn't be particularly useful. So again, in the bottom bus stop, I'm going to write the number we are going to divide by. And then I'm just going to pick one of these numbers here. I'm going to pick 2. So we're going to firstly divide our number by 2, not 8 as I did over here. So 2 into 5 goes twice, remainder 1. 2 into 16 goes 8 times. 2 into 3 goes once, carry over the 1. And then finally 2 into 12 goes 6 times. So I've done the first part. So I have divided it by 2. Now, hopefully you guessed it right, I am now going to divide by the other factor, which was 4. So 4 into 2 doesn't go, 0 goes up there. 4 into 28 goes 7 times. 4 into 1 doesn't go, so we scratch it off, carry over the 1. 4 into 16 goes 4 times, and as you can see, we end up with 704, exactly the same as what we did over here. So that is basically the double-decker bus-stop division. It is a way of when those numbers get bigger and bigger and bigger, and if you're not confident by maybe dividing by 9, maybe 12, 8, then you can use this method to break those numbers down into smaller numbers and then divide by them then. I'm going to go over a few more examples about how this method can be really, really useful on the next slide, where I've got a blank page. Okay, this is the second example we're going to look at, and we're going to be looking at 1,344, and we're going to divide that by 12. No, we're not. We're going to divide it by 24. We're going to make it even harder for ourselves. Now, I've picked this number specifically because immediately, if we weren't dividing it by more of a familiar number that we were dividing by, usually a number between 1 and 15, probably not 14 and 13, but by dividing it by 24, immediately we go, well, I don't know my 24 times tables, and so that often then has to go into another method of division, maybe like long division or chunking. But this is where double-decker bus-stop division can support dividing by larger numbers as well, and I think is a really, really nice method for doing this. So first things first is we need to pick a factor pair of 24 before we can start doing anything. So factor pairs of 24, if we were to write them down, we've got 3 and 8, 2 and 12, 4 and 6. I think, yeah, that'll do for the list. I don't think there's many more than that. So what we're going to do is we're going to pick one factor pair to focus on. I'm going to pick 4 and 6. So we've got 1,344, and I'm going to divide firstly by 4. It doesn't matter if I was to divide by 6 first, because we're going to get exactly the same outcome. But I'm going to divide it by 4 first, and then we'll see what we get afterwards. So 4 into 1 doesn't go, so we carry over. 4 into 13 goes 3 times, remainder 1, carry over the 1. 4 into 14 also goes 3 times, and that carries over 2. And then finally 4 into 24, that's going to go 6 times. So now moving on to the bit above, we're dividing by 6. So 6 into 3 doesn't go, carry it over. 6 into 33 goes 5 times, remainder 3, carry over the 3, and 6 into 36 goes 6 times. There we go, job done. So that would give us 56 there. Now, there's another little trick we can actually do with this. I'm adding another layer to the bus stop, and what I'm going to do is I'm going to split up the 4 into 2 2s, because a factor pair of 4 would be 2 and 2. So we could actually have divide by 2, divide by 2, and then divide by 6, or we could do those in any order. And I'm just going to show you what happens when we do this. So 2 into 1 doesn't go, carry over that. 2 into 13 goes 6 times, carry over the 1. 2 into 14 goes 7 times. 2 into 4 goes twice. 2 into 3 goes 3 times. 2 into 7 that goes 3 times, remainder 1. And then 2 into 12, that goes 6 times. Now we're on to the home stretch. 6 into 3 doesn't go, carry over. 6 into 33 goes 5 times, carry over we've got 3 left over. 6 into 36 goes 6 times, and look at that, exactly the same answer. So again, you can just break down, and we could even have broken down the 6 into 2 and 3. So then we could have then just divided it by 2, divided it by 2, divided it by 2, and then divided it by 3, and then that list could have gone on and on. So it's a nice way of breaking down those larger numbers. Now this method does have its limitations, so just have a little think about that for a second. If we wanted to pick a number, and it's not necessarily the number we're dividing by. Well, sorry, it's not necessarily the number that we're dividing, but it's the number that we're dividing by. So if our number was, say, for instance, 17. Now this would obviously cause a few problems, because what are the factor pairs of 17? There's only 1 and 17. It's because it's a prime number. Then this method isn't probably going to be the most, you're going to have to know your 17s times tables, so you'd have to go to long division or chunking to solve this one. So it's when those numbers aren't prime numbers that it becomes a bit of a problem. But any kind of number that isn't a prime, that can be broken down into smaller factors, this is a brilliant example of where we can use double-decker bus-stop division. Well, I hope this has been useful, and yeah, watch out for more.